Today we're going to look into the more detailed part of trigonometry and see how these functions, these trigonometric functions, are actually applied, and look at some examples as well. So let's get straight into this. Before we get into what these functions actually mean and how we apply them, we need to recap over how we label a triangle relative to a particular angle. So in this case, we've got a right-angled triangle with an angle of theta over here. And when labeling the sides, make sure you go for the hypotenuse first, because that's the most obvious one. That is the longest side of the triangle. So we just label that hypotenuse there. Okay, hypotenuse, it's always opposite to the right angle of a right angle triangle. Okay, that's the hypotenuse. Then we label the opposite, which is exactly opposite to the angle that we are measuring relative to. So this side will be the opposite because it's literally opposite to the angle, and the remaining side is called the adjacent, which just means it's next to the triangle, next to the angle that we're measuring from. So now we just apply these. Well, we need to know what they mean. So we've got sine, cos, and tan, and you just need to remember this mnemonic type thing, which is SOHCAHTOA. Just stick this in your head. It's really helpful regarding trigonometry. So we've got sine, which represents so. That basically means these two letters, at least, they represent the initials. They are the initials of the two sides, or one of the three sides in your right angle triangle. So we've got S just basically means sine, cos for C over here, tan for T over here. The first letter within this mnemonic is just the initial of the function itself, and the next two are the initials of the sides. So we've got O, which denotes the opposite, and we've got H, which just represents the hypotenuse. And then we've got cos over here, we've got which just A represents the adjacent, and then the hypotenuse for tan, the opposite, and the adjacent. So what we do is we basically use the function sine, and we apply it to a particular angle. In this case, let's say it's this angle, sine theta, and that always turns out to be the same as the opposite over the hypotenuse of the angle. So basically, let's say we've got this triangle, and we know what that angle is, and to find out a particular side, let's say the opposite, we use, and we're given the hypotenuse, we use this function sine, and we rearrange that to make opposite subjects. So I'll do a quick example here. We've got 30 degrees over here, a right angle triangle with an angle of 30 degrees, and the hypotenuse is of, let's say, 10 centimeter length, and you want to find out this side. Okay, the very first step that you should do is label your sides. This is the opposite, that's the hypotenuse. The hypotenuse we've already been given is 10 centimeters. And then the next step is, since you remembered that, you go to your SOHCAHTOA, and you basically look for the combinations of sides that you know and you're given, or at least one of them which you're trying to find out, which is the most common case. So in this case, we don't know, we want to know the opposite, and we're given the hypotenuse. So let's look at tan. Yeah, it contains the opposite, that's useful, but it's saying that we also need the adjacent. So we can't really use tan because we don't know what the adjacent is. So we'll go on to the next one. We look at cos, and this tells us to use the adjacent and the hypotenuse. Well, we've got the hypotenuse, but again, we don't know what the adjacent is, so that's pretty useless as well. And I mean, it doesn't even contain opposite, which we're trying to find out, so that's not useful at all. So then we're left with sine, and we look at sine, it says the opposite and hypotenuse, exactly what we're given, and one of them which we want to find out. So what we do is as I mentioned, we apply these functions to the angle that we're measuring relative from. In this case, it's that angle 30. So we do sine 30, and that is always equal to, we go up the opposite over the hypotenuse. The letter in the middle is the numerator of the fraction over here. So opposite, so O is basically the numerator goes on the top and H goes at the bottom as a denominator. Okay, sine 30 is equal to the opposite over the hypotenuse. The opposite we don't know, so we just write it as the opposite over the hypotenuse. We know what hypotenuse is, it's 10 centimeters. And we rearrange that to make opposite the subject, which is simply opposite equals sine 30, if you plug it in your calculator, is 0.5. So 0.5 times by 10 centimeters equals 5 centimeters. So in this case, that side opposite is 5 centimeters. Don't forget your units as well, which are very important. So yeah, that's one way of using trigonometry to find out sides, missing sides of a triangle. And should we go into the angles? No? Alright. We'll go into the angles in the next video. Thank you for watching.